Good morning, students. Welcome you all for next generation learning. Today, we are going to see the subject physics and class 10, chapter number 11, human eye and colorful world. Topics. Today, I am going to discuss how to draw the diagrams in this chapter. The first diagram is structure of a human eye. Look at this image. This is a structure of human eye. When you are drawing this diagram, you have to mark the parts correctly and see. The first you have to draw the cornea. This is a cornea. It placed front of the eye. It must be pledged. The next you have to draw iris. The small line. See here, this is a small line. This is called iris. In between of these two iris, we have some gap that is called pupil. Then crystalline lens. This is a crystalline lens. Here the crystalline lens are holded by the ciliary muscles. So this is a ciliary muscles. These ciliary muscles are connected at end to end. It must be attached to the eye lens. At back, this is a retina. This is a retina. Here the retina and optic nerve are connected at each other. This point is called blind spot. And in between of retina and eye lens, the vitreous humor is filled. In between of iris and cornea, the aqueous humor is filled. So when you are drawing this diagram, you have to mark the first part: crystalline lens, aqueous humor, pupil, iris, cornea, ciliary muscles, retina, optic nerve, vitreous humor. The one part is missed, that is called blind spot. Here you have to mark blind spot. And also when you are drawing the ciliary muscle, it must be attached to the eye lens and also it must be connected in this direction. The next diagram, defective myobic eye. You know that what is meant by the myopia. In theory, we learned that in a myopic person can see the nearby object clearly. They cannot see the distant object clearly. So how to draw the defective myopic eye? So this is called retina. So you have to write retina here, and this is eye lens, and this is a cornea. In a myopic person, the image is formed in front of the retina. That is called defective myopic eye. So when the object rays are coming from the infinity, the image is formed in front of the retina. So here I written image is formed in front of the retina. Here the object is placed at infinity. In a myopic person, they cannot see the object at infinity. Why we cannot see the object at infinity? Because the image is formed in front of the retina. So whenever they are asked the question, you have to draw the defective myopic eye. You have to draw this diagram. And you have to write in a for myopic person, image from the infinity is formed in front of the retina. It is not formed on the retina. And the next one, fair point of a myopic eye. What is meant by the fair point of the myopic eye? At up to which distance the person can see the object clearly, that is called fair point of the myopic eye. For fair point of the myopic eye is less than the infinity. If maybe the object is placed at infinity, the person cannot see that object. The, the object is placed less than the infinity means the image is formed on the retina. That is called fair point of the myopic eye. See here, here the fair point is represented by the letter EF. So the rays are coming from that fair point, and after refraction it meet at the retina, so the image is formed on the retina. So whenever they are asked to draw a fair point of a myopic eye, you have to draw this diagram, and also this word is a very important word. Fair point is less than the infinity. The next one, correction of myopic eye. So how to correct this myopic eye? Using concave lens, we can correct the myopic eye. How? When we placed the concave lens in front of the myopic eye, this is a fair point. The object is placed at infinity. So the ray coming from the object or fall on the concave lens. When the object is placed at infinity, in a concave lens form the image at focus. So this is a fair point of the myopic eye. So these rays are again passing through into the crystalline lens, and the image is formed on the retina. So using a concave lens, we can correct the myopic eye. So whenever you are drawing this diagram, you have to write concave lens to correct myopia. Rays are first diverged from the concave lens. So this is a rays are diverged from the concave lens. The diverged ray are only pointed by the dotted lines. And retina you have to mark it, and image is formed at retina you have to mark it. And this continuous line are nothing but the rays are coming from the infinity. The next one, what is meant by defective hypermetropic eye? In hypermetropic person, you know that hypermetropic person, they can see the far object clearly, they cannot see the nearby object clearly. So when the object is placed at near to the eye, the image is formed behind the retina, so that hypermetropic person, they cannot see the nearby object clearly. You have to write normal near point N here, then I means the image formed behind the retina. So image formed behind the retina, you have to write it. The next one, what is meant by the near point of a hypermetropic eye? For near point means up to which lowest distance the person can see the object clearly, that is called a near point. For normal eye, the near point is 25 centimeter. So when the near point of a hypermetropic eye, here the near point of the hypermetropic eye is more than the 25 centimeter. So the image is formed at retina. And how to correct a hypermetropic eye? Using convex lens, we can correct the hypermetropic eye. When we place the convex lens in front of the cornea, the object is placed here. So the first rays passing through this convex lens. When the object is placed at focus, the image is formed at infinity. So this is image. So again this image rays are travel into the crystalline lens and the image is formed at the retina. In this image, in this diagram, the continuous lines are drawn here. Sorry, the dotted lines are drawn here and the continuous lines are drawn here. The next one, refraction through a glass prism. So look at this diagram. In a refraction through a glass prism, you have to draw, first you have to draw triangular shape and you have to give the name A, B and C, then write glass prism here. You know that it is a glass and it is air, this is air. The ray travel from air to glass and this is a point of incidence, so I draw the normal line. And here the refraction taken place. This is a refracted ray. So here I draw the normal line. There are the two normal line. Here the ray is travel from glass to air. So the emergent, again the refraction happen. This is called emergent ray. So you have to mark the arrow mark. You have to put the arrow mark. This is incident ray, refractor ray and emergent ray. Then three angles are present. One is angle of incidence and angle of refraction and angle of emergence. The angle between incident ray and normal is called angle of incidence. The same as the refractor ray, and this is a normal line, that is called angle of refraction. The same as this is an emergent ray, this is a normal line, this is an angle of emergence. If I draw the incident ray at back and emergent ray at back, these two rays are meet at this point. This is called angle of deviation and it is clearly shown here. This is an incident ray and this is a refractor ray. So these two rays are meet here. So it is called angle of deviation. So when you are drawing this diagram, you have to mark incident ray, refractor ray, emergent ray. Then angle of incidence, then angle of refraction, then angle of emergence, then angle of deviation. There are the 4 angles are present and 5 angles are present. One more is angle of prism. This is angle of prism. 3 rays are present: incident ray, refractor ray, emergent ray. 5 angles are present. One is angle of prism, an angle of incidence, angle of refraction, angle of emergence and angle of deviation. The angle of deviation is nothing but if you draw the incident ray in this way and emergent ray at the back, these two rays are make an angle. That angle is called angle of deviation. The next diagram is dispersion of white light by a glass prism. So when this is a glass prism, when the white light is passed through, it is dispersed into 7 colors. That is called dispersion of light by a glass prism. So when you are drawing using pencil, you have to draw in this way. This is a prism and you have to write a name, glass prism. Then white light, you have to draw this one ray, a ray with arrow mark. This is, you have to give a name, that is white light, because the white light only dispersed into 7 colors. And these are the 7 colors, and you have to write violet, indigo, blue, green, yellow, orange and red from the bottom to top. And you have to write this is a screen and this is a spectrum. You must be write glass prism here, the white light here, and here also you have to put arrow mark. For in each line here also you have to put arrow mark. Without arrow mark, if you're drawing the without arrow mark, the diagram is wrong. Because without arrow mark, this is called a line. When you put arrow mark, this is called light ray.